Algebraic expressions, the basics. An algebraic expression is a combination of numbers and variables using the operations add, subtract, multiply, and divide, as well as powers or roots. So note, there is no equal sign in an expression. If there is an equals, it is an equation. Okay? So that's the terminology we need to keep straight. Expression and equation. Equation has an equals in it. All right, so in an algebraic expression, the combination of numbers and variables separated by the addition or subtraction operations are called terms. This means that terms are separated by pluses or minuses. The sign goes with or belongs to the term that follows that sign. Okay? So now when you're working with expressions, you may have an expression and then you may see somebody write equals and something else and equals. You're just saying that expression is equivalent to the next one. You didn't start out with an equal sign in your equation and solve for a variable or something. So here you're simplifying expressions or something like that. So we're not solving for in an equation for a variable. If there is a number combined with a variable, then the numerical part of the term is called the numerical coefficient. Two or more terms are considered to be like terms if the variable part of each term is the same. So you have a numerical coefficient and then you have the variable part of the term. If the variable parts of the term are the same, then you have like terms. If there's no variable that exists within a term, it is known as a constant term. So let's talk about some of this terminology. So for part A, I want you to say how many terms are in each algebraic expression. Part B, what is the numerical coefficient of the first term? Part C, what is the constant term? Part D, are there any like terms? If they are, list them. And then, what is the second term of the algebraic expression? So let's look through here. Part A, how many terms are in this? So look, we see a plus sign. That means one term here and another term here. That's how many terms? Two. Two terms. All right? So two terms. And then for part B, what is the numerical coefficient of the first term? Here's the first term. What's the number part of that? 7. 7 is the numerical coefficient of 7x. 7x is the first term. What is the constant term? Well, here's a constant term. And notice I circled the plus sign because pluses and minuses separate the terms, but the plus sign goes with what follows it. It goes with the 3. It doesn't go with the 7x. So 3 is the constant term. If you don't put a plus sign there, it's understood to be positive. Now, if you're combining or writing two terms in a row, you can't just assume the second term is positive. You've got to put a plus. But if it's the first and only thing you write down, if you don't write a sign, it's understood to be positive. Are there any like terms in this algebraic expression? Any like terms? Remember, like terms have the same variable part. So here this has x. This doesn't have an x. Those are not like. So here, are there any like terms? Nope, there's not. And then what is the second term of the algebraic expression? So here, first term, second term. Second term is 3. The second term is 3 there. All right, what about the next one? How many terms? Well, 1, 2, 3, right? You got two plus signs there that are separating. The y is the first term, the 5 is the second term, the 9y is the third term. So there's 3 terms here. Part B says, what is the numerical coefficient of the first term? The first term is simply y. So what number is multiplied by y? Well, if you see a y, there's at least how many there? 1. So if it was 0, you wouldn't see a y. So the coefficient there is 1. This is like 1y. We don't write that 1, but it is there. We don't write 1y, but we understand if there's a y there, there's a 1 times it. For C, what is the constant term? Well, this has a variable, this has a variable, so there's your constant term is plus 5. And again, we don't have to write plus there, we just write 5. And then, are there any like terms? And here, we have a y term and another y term, so what are they? So the answer is yes, y, and what else? 9y. Those are our like terms, okay? And then E, part E is going to be, see if I can get rid of that without erasing the 3 terms here. Part E says, what is the second term? So the second term here is 5. The second term here is 5. And then for part A here, how many terms? Well, there's 1. Then you have that term is 2, 3, and 4 terms there, right? 4 terms. So this has 4 terms. Part B says, what is the numerical coefficient of the first term? Well, here's the first term. What's the number of times that first term? It's 4. Now, by the way, the first term doesn't always have to be positive. It could be negative 6x, and then negative 6 would be the numerical coefficient of the first term. So I realize all these are positive, but it could be a negative coefficient. What is the constant term? Well, here, variable, 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 there it is. So plus 11. So 11 is my constant term. Part D says, are there any like terms? So we got x, we got y, we got a number, and we got a constant term, and we got w. None of those are alike. So are there any like terms? Nope. And then finally, it says, what is the second term of the algebraic expression? Negative 3y. There's the second term of the algebraic expression. Negative 3y. All right? So that's A through E for all three of those algebraic expressions. So what if we want to do a little work, simplify the algebraic expression? So here we want to take the algebraic expression x plus 7, and we want to multiply that by 5. We want to multiply this. So what we're going to do, when we have 5 outside of parentheses, we use the distribution property. So we use distribution. We distribute the 5. So the 5 gets multiplied by the x. So what we're really doing is 5 times x plus, this is a positive 5 and a plus here, so that leaves me with a plus. Plus what? Well, 5 times 7. Now, I'm showing you what's happening here. You don't have to show that. If you, as a student, told me, Mr. Guest, I did that in my head, I would believe you. Just make sure you understand what your teacher, your professor wants if you're in someone else's class. So here we have 5x plus 35, and that is simplified. You can't combine those are not like terms, so you're done. 5x plus 35, you're done. So let's look at the next one. 8, and then parentheses, x plus w. So we're doing the same thing here. We're taking the 8 times both of these, and we're going to say 8x plus 8w. 8x plus 8w. We're taking the x and we are distributing it to the x and the w. Then we have 4 times 5x minus 9. So we're going to take this 4 and distribute it. So this is going to be 20x, so 4 times 5x, right? 4 times 5 is 20, and then we have x, minus, right? A positive times a negative is negative. 4 times 9 is 36, so 20x minus 36. Then we have 1/5. So I'm going to go back and do something I did on the first one on this page. I'm going to show this step here on this next one, okay? Over here. So I'm going to say this is distributed, right? So I'm going to show 1/5 times 15x minus 1/5 times 25. So how on earth do I do 1/5? 1/5 times 15. So if you recall, an integer times a fraction, the integer 15 or 15x, that term is over 1. Will we ever answer over 1, or will we ever write 15 over 1? No, we would never do that. We're just reminding ourselves, hey, the 15 is in the top, the numerator, the 5 is in the bottom of the denominator. When that's the case, you can divide those out. You can divide out anything this is being multiplied. Anything multiplied can be divided out, top, bottom, numerator, denominator. So here the 15 and the 5 goes into 5 once and the 15 3 times. So we're left with 1 times 3 times x, which is 3x over 1. But do we write over 1? No, if you write over 1, then just say, hey, wait a minute. If the only thing left in the bottom or denominator is 1, I don't write that. So I just write 3x. So if you write 3x over 1, just write it down again with 3x or erase the over 1 part. You never leave over 1. And then minus, because you got a minus sign here. Minus what? Well, and there's nothing here to change that, right? It's not a minus times anything else, so other than a positive. This is over 1 as well. How many times does 5 go into 5? What about 25? 5 times. Then you have 1 times 5 is what? 5. And then down here, over 1. Over 1, but do we write over 1? No. So the final answer is 3x minus 5. And again, if you wrote this down, then you just turn around and go to the next step and write that down. Okay? So 3 times 2x minus 3 plus 8y. So here, we're going to take this 3 and distribute. And we're going to get 3 times 2x is what? 6x. right? Distribute, right? 3 times 2x. And then we take 3 times negative 3. So a positive 3 times a negative 3 is negative 9. And then we take 3 times a positive 8y. So 2 positives gives me plus. 3 times 8 is 24, and we have a y there. Are there any terms there that are like to combine? There are not. So 6x minus 9 plus 24y. And then we have 7x plus 15x. So here there's nothing to distribute, right? There's no parentheses there. It's just 7x plus 15x. So those are like terms. We're going to combine those like terms. We have 7 of something and we add 15 of that something, and we have what? 7 plus 15 is 22, and we have 22 x's, okay? That's like having $7 plus $15. You have $22. You don't have $22 squared or 22 something else. You have $22. So you have 22 x there. 7 apples, 15 apples, add them together, 22 apples, right? So the power there doesn't change. The x doesn't change. That's what you have, right? So then we have 12n minus 6n. Again, we have 2 terms here. They're like. So we're going to combine those. We're going to put them together. 12 minus 6. So like if we had 12 rocks minus 6 rocks, we have what? 6 rocks. So we have 6n. $12 minus $6 is $6. It's still, if you combine like terms, you get a like term. Okay? And we'll talk more about that in future videos on combining like terms. So here, 4y plus 11 plus 12y. Do we have anything in there that are like? Yep, we have the y's, right? So this term and this term are alike. So 4 plus 12 is how much? 16. That's 16y, and then we just bring down the plus 11. So 16y plus 11. And the next one, 13 plus 2, and then open parentheses, 5x plus 1. This one, we're up in the ante a little bit, okay? And we're going to get more into this later with order of operations. But here, what do I do first? Remember, I got to multiply before I add. See, the 13 is added to the 2, but the 2 is multiplied by the parenthesis. So if we take this away, that's basically what those first few problems were on the page before where we distributed. So the first thing we want to do is distribute the 2, and it's important we're distributing a plus 2. So the 13 stays out front. We have a 2 times a 5x is plus 10x. See, that's where you can't assume the 10x is positive. You can't write 13 10x. That would be 1,310x. You've got to put the 13 is positive. It's first. You don't have to put a plus in front of it. But the 10x is another term, so it must have the plus there to say, hey, I'm a new term. Okay, but I'm positive. And then plus 2 times plus 1 is plus 2. Now do I have like terms? And the answer is yes, I do. I have 13 plus 2, which is 15, and then plus 10x. All right? And that's simplified. Now, sometimes, make sure if you're told to put in a descending order, you turn it around and put 10x plus 15. All right? So, but it's okay here that we're not told that. So we can put it in whatever order we want to. But we do need to simplify the 13 and the 2 to get 15. The next one, 9 and then 5m plus 2n in parentheses plus 4 and then 10m plus 7n in parentheses. So what we're going to do is distribute the 9. 9 times 5m is 45m, and then 9 times 2n is plus 18n. So that's that 9 distributed to those two terms. Then we have a plus sign, right? That's how we know we're not multiplying that 9 or that parenthesis by the 4, because there's a plus to separate it. But the 4 is written beside the parentheses with the 10m and the 7n, right? So on that, we are going to take this plus 4 and distribute to these two terms. So that a plus 4 times 10m is plus 40m. A plus 4 times 7n is plus 28n. And then we are going to combine like terms if we have any. Do we have anything like the 45m, the plus 40m? What is 45 plus 40? That is 85m. And then we have the 18n. I'll put 2 underlines under the n's. 18 and 28 when we add them together. Well, look, I add the 10 and the 20 and get 30, and then I have 8 plus 8, 16, and what is 30 plus 16? It's 46. So this is going to be plus 46n. Plus 46n. in. So this is just an introduction. We're going to talk more about combining like terms, videos for that with real numbers and with expressions, with terms with variables. All right, so I hope this helps with algebraic expressions.